Hello everyone, you are welcome to the GMAT 41's Basic Mathematics class. In this video lesson, I'll be teaching you how to write numbers in expanded form, whether whole number or decimal numbers. This video lesson actually introduces us into part 4 of numbers and numeration. You would recall we've treated part 1 to 3 of numbers and numeration, where we treated place values and their standard values, whether it is whole number or decimal number. I also taught you how you can get the value of a digit in any given number. You also recall that we've treated under this number and numeration how to write numbers in words and in figures, whether the number is a whole number or a decimal number. So straight ahead, we'll be moving on to writing numbers in expanded form. But as always, I would like to tell you the secret. Good enough, in writing numbers in expanded form, we've already learned the secret. And so as I tell you the secret, if you still have any issues with any one of the 2 secrets I'm going to give to you, please just pause this video, go back to them, and make sure you solve any problem you have in them before you continue with writing numbers in expanded form. This will help you to appreciate this topic and learn easily how you can write numbers in expanded form. Secret number 1. To be able to write a number in expanded form, you need good knowledge of place values. Very simple, isn't it? If you take a mind back to when I taught you place values, you see how simple it is, both for whole numbers and for decimal numbers. So you need the knowledge of place values, is that okay? And then secret number 2, you need to know how to get the value of any digit under any given place value. Now you recall when I taught you that, I told you that if you give me a number and ask me to find the value of any digit in that number, all I have to do is to multiply the digits by the standard value of the place value of that digit. That is what you do. So these are the 2 secrets you need in order to help you appreciate this topic we are going to treat in this video lesson. Writing numbers in expanded form. Now we're going to treat both for whole numbers and for decimal numbers. Do you think you're ready for this class? I am ready. So if you are, then let's kick off. Alright? I'm going to carry you through teaching you how you can write numbers in expanded form. I would also teach you how you can get the number represented by a given expanded form. To start with, please take a look at these numbers at the board, alright? The first one here, I have 7,000 plus 200 plus 10 plus 5. This number, which number does it represent? 7,000 plus 200 plus 10 plus 5. So which number is represented by this? Alright, look at the second one. The second one we have 30 plus 4 plus 0.02, okay, plus 0.2 plus 0.2 plus 0.06. Which number is represented by this expanded form? Now let me tell you something very interesting. At least from this I can tell you that the first number is the expanded form of one particular whole number. But that whole number we don't know yet. At the end of this lesson you will get to know that number. How did I know that the first one, 7000 plus 200 plus 10 plus 5 represent a whole number? Simple, because there is no decimal point in any of the numbers there. Are you getting me? That's how I got to know. There is no decimal point in any of the numbers. 7,000 plus 200 plus 10 plus 5. Then the second one clearly is a decimal number. How did I know that it is a decimal number? Of course, you can see for yourself. You can see the decimal digit 0.2. You can also see 0.06. So because in that number 30 plus 4 plus 0.2 plus 0.06. It contains decimal points. That simply tells me that that number is the expanded form of a particular decimal number, which of course you are going to find out at the end of this lesson. Now we're going to solve questions on whole numbers and on decimal numbers. So are you ready? Now let us start with writing whole numbers in expanded form. Our very first question, number 1. And this question here on the board reads, write 999,473 in expanded form. So how do we do this? It's really very simple. Remember the two secrets. Know the place values of the digits in this number, 999,473. Then find out how to get the values of each digit. Let's just go around this and see. This is already in hundreds of thousands. If you want, you put the place values. Once again, I would like to start with place values. Hundreds of thousand, tens of thousand, hundred, tens, and unit. And we fix up the digits under the correct place values. This is 374,999. Therefore, 999,473 in expanded form will now be, how do we go about it? Take note of this. This is where values of the digits will now come into application. We are going to use each digit here to multiply the standard value of its place value. Then we put plus, right for the second one, plus, right for the next one, then till we get to the last digit. Are you there? So we start with this 9. 9 is under 100,000. The standard value of 100,000 is 100,000. So this is 9 times 100,000. Does that make sense? 9, this digit, times 100,000, which is the standard value of this place value, hundreds of thousands. Then I'll put plus, come to the second 9. 9 times, this 9 is under tens of thousand, and the standard value of tens of thousand is 10,000. So this becomes times 10,000. And if you look at this, this is exactly how we get the value of a digit. Is that not so? So I'm going to do plus, come to the next one. 9 times, this is under 1,000, and the standard value of 1,000 is 1,000. Then plus 4 times 100, because 100 is the standard value of 100, plus 7 times 10, because 10 is the standard value of tens, plus 3 times 1, because 1 is the standard value of unit. That's all. We can decide to rewrite the result like this: 999,403 to be equal to 9 times 100,000 is 900,000. How do you get that quickly? Simply use this 9 to multiply this one, and you will get 9. Then attach the number of zeros you have there. And how many zeros do we have here? 5 zeros. So it is 900 and then 1,000 plus, do same here, 9 times 1 will give us 9. How many zeros do you have here? 4 zeros. So that is 90,000 plus, come over here, this will give us 9,000. 9,000 plus, if you work on this, you get 400. 400 plus, this will give us 70, which is 7 times 10. And then conclusively, 3 times 1 will give us 3. And this is the expanded form of 999,473. As we move on next, I will show you this place value again. I expect that by now, you already have your place values at heart. Is that okay? You know them and you can say them offhand. Let's move on to question number 2. Meanwhile, this is the expanded form: 900,000 plus 90,000 plus 9,000 plus 400 plus 70 plus 3. The expanded form of this number. Question 2. And here is our second question. We are asked to write 189,533,006,521 in expanded form. Now, how do we go about this? If you look at this question number 2, the number is given to us in words. Now, when you're writing expanded form and the question is given such that the number is in words, it is advisable that you change it to figure. Alright, it's going to help you so as not to land yourself in trouble. I can actually solve the question without first changing this thing to figures. But to help you understand it best, I am advising it is always good to change it to what? To figures first. But the only thing I won't do here is I will not take my time like I did when I was teaching you how to write numbers in figures when they are given in words, how to change it from words to figure. I won't waste time talking about the place values and the rest. Is that okay? Or writing them out. I'll simply remind you that you need to identify the standard place values in this number so as to make it easier for you to write the numbers in figures. And what are the standard place values? We have 189 billion. So the first standard place value I heard is billion. Then 533 million. The next one is million. We have 6,000. Alright. 6,000. Then 521. Now, this 521 is in 100 tens in unit. Are you following, right? This 6,000, operating in this 1,000 is simply the digit 6. Now, following this, let us see the numbers attached to these standard place values are what? For the billion, we have 189. How do you write 189? Look at it, 189. So you're going to have 189 billion. So this is comma, all right? Good. We move on to that of million. The number attached to million, operating in the place values of million, is 533. Now, if I pronounce the word or the number 533, how do you write it? That's correct. You can say that 533. So this gives us 533. And then the next, we move on, we have 6,000. Now this 6,006, 6 is just one digit. And one digit, you know, is unit. Which means this 6,000 is operating under the unit of 1,000. And unit of 1,000 is simply 1,000. Now if you come to 1,000, you know we have 1,000, we have 10,000, and we have what? Hundreds of thousands. That is the arrangement. But in this number, it's only 6 that is given to us, which means that 6 is under unit of 1,000, which is simply 1,000. Therefore, tens of thousand and hundreds of thousand are empty place values. And for any empty place value, what do? Fix 0. That's good. You fill it up with 0. So we have 006. This is 6,000. Then conclusively, we have 521. 521, how do you write it? 521. Good. 521. So this is this number written in figure. Alright, 189 billion 533 million 6,521. We have to write this number in expanded form. So what do? Simple, we start. By now, you should already be working out the place values of this down upstairs there. Is that okay? Should be working it out. You should know your place values. I told you I wouldn't write out the place values, okay? Now I know that this one is operating under the place value of hundreds of billion. So what will I do? I will pick that one, then I'll use it to multiply the standard value of this place value, which is hundreds of billion. The standard values of hundreds of billion is simply 100 billion. And 100 billion is written like this. You write 100, then fix up 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. Plus, this is going to give us a lot of zeros. I think this question, after getting the answer, I would write it in standard form for you, powers of 10. So that, because the zeros are too many. So we move down to tens of billion. The digit there is 8. So it's going to be that digit 8 times the standard value of that place value of tens of billion. And standard value of tens of billion is 10 billion, which is written as 10 and then 9 zeros. And then next, we move on to the unit of billion, which is simply billion. The digit there is 9, so it's going to be 9 times 1 billion. 1 billion is the standard value of billions. Is that okay? Good. So it's going to be 1 and then followed up by 9 zeros. This will now move us down to the next lower place value we have there, which is millions. And then the first one is this 5, under hundreds of million. The standard value of hundreds of million is 100 million. So we're going to pick this 5, that digit there, and then we multiply it by 100 million, written as this, 100 and then 6 zeros. 100 and you attach 6 zeros. That's 100 million. We move to this 3 plus the next one. We're going to use 3 to multiply. This 3 is under tens of million, and the standard value of tens of million is 10, and then you attach 6 zeros. So this is 10 million. Alright, plus the next one is this 3. We pick it and multiply it by the standard value of that place value. This 3 is in unit of million, or simply million, and the standard value is 1 million. So you write 1, attach 6 zeros. We are now moving down to thousands. Are you there? So this 006 is in thousands. Now you can decide not to bother yourself working out for this 0 and this 0. Because if you do 0 times any number, you get 0. Is that okay? 0 times a number, you get 0. But not 0 times 0 anyway. But don't bother yourself about that one of 0 times 0. As you move on in your studies, you would meet that and learn that 0 times 0 is meaningless. But for now, let's just generally say 0 times any number is 0. Okay, now, so you can decide not to punish yourself writing these zeros, because 0 times the standard value of their place values here will give you 0. But just for the purpose of clarity and understanding, for you to get what we are doing here, I will show it to you. So coming here, I will do this 0 times the standard value of its place value. This is hundreds of thousand. Hundreds of thousand, the standard value is 100. Then you fix up 3 zeros. Then plus the next one is 0 times, this is tens of thousand. The standard value is 10,000, so you write 10 and then you fix up 3 zeros. The next one is this 6. 6 is under unit of thousand. The standard value of this is simply 1,000. So 6 times 1,000. Alright, 6 times 1,000. 1,000 is the standard value of this place value here. Let's now move down to our hundred tens and units. 100 tens and unit. 5 is under the place value of hundreds. So it's going to be 5 times 100. And then plus 2 is under tens. The standard value of tens is 10. Plus 1 is under units. The standard value of unit is 1. So it's going to be 1 times 1. Alright, let us get the value and see. 1 times this 100 billion will give us 100 billion. 100 billion. So let's see. Good. This is 100 billion. Next, 8 times 10 billion will give us 80 billion. I've told you how to get the answer of that. How you can multiply fast. I showed you in question number 1. So 80 and then billion. Billion is 9 zeros. And they have 80. An extra 0, making it 10 zeros altogether. The next one is 9 times 1 billion, which will give us plus 9 billion. Right, we are moving. This takes us to that of 5. 5 times 100 million will give us 500 million. Simply 5 times 1, you get 5. Then you attach the number of zeros here. Or simply 5 times 100, you get 500, and then these 6 zeros. The choice is yours, however you want to multiply it out. 500 million. Then plus the next one is 3 times 10 million, which is 30 million. Right? And then this takes us to this. 3 times 1 million will give us 3 million. Alright? And then coming to this, 0 times 100,000 is 0. So permit me to just cancel it, okay? It won't exist. Again, 0 times 10,000 is 0. Permit me to cancel it. It won't exist. Then this takes us to 6 times 1,000, which is 6,000. And then plus 5 times 100 is 500. Plus 2 times 10 is 20. Plus 1 times 1, the last, is 1. So this is our answer. This is our answer. But like I said, because of the many zeros you have there, I am going to rewrite this answer in standard form as a power of 10. Is that okay? So let me do that here. I'm going to put or. Now how do we write this in standard form? It's simple. If you take your mind back when I taught you place values and the standard values of the place values, both for whole numbers and for decimal numbers, I showed you how to write these standard values as a power of 10. That is in powers of 10. Alright, so we are going to do that here. The powers of 10 is simply the number of zeros you have in these numbers. But this is how we go about it. So let me use blue marker in showing that, okay? I will come to this, I will pick the first non-zero digits. That is the first digit you have in all these numbers here, in each of them. Here, the first digit I have is 1. So I will bring out that 1. So I'll say, oh, this is equal to, I'll bring out that 1. Then I'll multiply it by 10 and ask myself, how many zeros are there in this 100 billion? If you count the number of zeros here, you will get them to be 11. So this will be 1 times 10 raised to power 11. Plus, we move on, this is 80 billion. The first digit, which is not 0 here, is 8. So you bring out that 8, you multiply it by 10, and then you ask yourself, how many zeros are there in 80 billion? And of course, if you count it, you're going to get 10 zeros. So this will be raised to power 10. Plus, the next is this 9. You bring out this digit 9, the first digit, multiply it by 10. Ask yourself, how many zeros do you have in 9 billion? It's going to be 9 zeros. So that's raised to power 9. You keep moving. This is 500 million. Bring out the 5, which is the first digits. The first non-zero digits. Non-zero, that is, that digit is not 0. So multiply by 10. And then raised to power, how many zeros do you have in 500 million? That's 8 zeros, so it's going to be power 8. Plus, you move again to this 30 million. The first digit there is 3. You multiply by 10 raised to the power of, how many zeros do you have in 30 million? 7 zeros. And this takes us to the next one, 3 million. You pick that 3, the first digit, multiply it by 10 raised to power 6, because there are 6 zeros in 3 million. Plus, now you notice that the next place you see yourself is 6,000. Pick that first digit 6, multiply by 10 raised to the number of zeros in that 6,000, which is 3 zeros, plus 500. Pick 5, multiply by 10 raised to the number of zeros you have in 500, which is 2 zeros. And then you go to 20 plus 2 times 10. In 20, how many zeros do you have? 1 zero. So power 1. And then plus the last one is 1. So you pick that 1. If you like to write it as times 10, is your choice. Then ask yourself in this one, if you pick this one times 10 to power, how many zeros can you see in this one? There is no 0. So it will simply be 10 raised to power 0. 10 raised to power no 0. Alright, so this is another way you can write the answer in standard form as powers of 10. Very amazing, right? Take your time, go through this, alright? We'll watch the video again. Because you can be asked to leave your answer in any of this form, either in this form, or in this form. Because in your quiz, after this lesson, you're going to see that. Let's move on to question number 3. In our third question, we have this number, 7,000 plus 200 plus 10 plus 5 is dash. Option A, 70215. Option B, 7215. Option C, A and B. Option D, I don't know. I don't like that. Option B, I don't know. You must know. Alright? After having seen how we handle question 1, 2, you just cannot tell me that you don't know. You must know. That's what the GMAT 41 is saying. You see, this question is very simple. It's simple. You have the idea of how to write numbers in expanded form already. So just from that expanded form, you can get back the number that is expressed in expanded form. So let's see that we actually know the answer. Forget about this option D. Alright, so in our solution, we have 7,000 plus 200 plus 10 plus 5. If you remember, this was the number in expanded form I gave you from the beginning of this class, alright? Asking which whole number is represented by this. Okay, now, how do we do this? There's a fast way of getting your answer. The fastest way you can do that is just picking the first digits. Like here, you pick your 7. That's the first non-zero digit in this 7,000. And if you do that, you're going to have something like 7. You come here, the first non-zero digit is 2. You come here, the first non-zero digit is 1. and you come here, the first non-zero digit is 5. Very simple, right? That is how we get our answer. Alright? But I don't want to be too quick in teaching you this. Because what if this number is given in such a way that a particular number is missing there? Maybe because the number is multiplied by 0 during the expansion. In question number 2, you saw something like that under hundreds of thousands and tens of thousands. You can check back in question 2. Are you following, right? Where we multiplied by 0 and the hundreds of thousands and tens of thousands disappeared from our final answer. So for that reason, I would like to solve this question fully, showing you how you can do that using your place values. Oh my God. Are we not tired of place values here? I will never be tired. And you didn't have any reason to be tired. Is that okay? Place. Very important. Don't joke with your place values. I've always said this. So that very first video on place value, okay, that video lessons on place value, make sure you keep watching it until place value becomes part of you, as if you are the one that developed that aspect of mathematics. For this question, we can simply extract the digit and get our answer. But like I said, I'll show you how to do that. But I'm going to solve it using our place values. How do we go about this? The first thing, check this first number. This first number is in thousands. This is 7,000, unit of thousand. It simply means that this number is given such that the highest place value is 1,000. And once you write the highest place value of any number, the next thing you take it to units. So this is 100 tens and units. So I will now come and do 7. I will put 7. I'll just extract this first digit and then write it under this 7. And of course, I'll come over here and then I'll take the first digit there, which is 2. Because this 2 is in hundreds, it means it's going to come under hundreds. Then this 10, alright, I'm going to pick the first non-zero digit, and then it will come under tens, you know that. So you pick 1 and fix that. And of course, this 5 is units, so you put it there. Therefore, we could say that 7,000 plus 200 plus 10 plus 5, the number it represents is 7,215. So 7,000 plus 200 plus 10 plus 5 is equal to 7,215. That's simply our answer. Now, I would like to show you question number 4 quickly. Alright, very important. I will tell you why I'm solving this question number 4. So that you will thank me for not being too quick to tell you that the fastest way of getting your answer here is just pick the first non-zero digits. Because if I had done that, then you would get yourself into serious trouble with this question you're going to see now. But before we move on to that, let's select our options here. Think 7,215, 7215. The correct option is option B. So I'll take that, alright? Option B is the correct option. Question number 4. Okay, which number is represented by 50,000 plus 500 plus 30 plus 3? Now, if I think I am too fast in solving this, it's just nothing, you know. I was told to just extract the first non-zero digits. Alright? Does that make sense? Let's change this one to something like, okay, let me put 6. Good. You see, I've extracted the first non-zero digits in each case. 5, 5, 3, and what? 6. And this gave me 5,536. Meanwhile, this number is in tens of thousands. This is 50,000. It's in tens of thousands. But what I have here is what? In thousand, not up to tens of thousands. So do you see that if I quickly go and extract the first non-zero digit, I will fail this question woefully. Does that make sense? That is why, even though there are other secret ways of fast way of handling certain things, I am never too quick at mentioning them. Because the way I will look at a particular question and say, this is what I can do quickly in it, someone else may not see it that way, or even if somebody sees that particular question, the person not knowing what I taught about before bringing out that format, that method, the person might start using that method for other questions, and failing seriously, it will seem as if what the person learned is wrong, which actually it is not wrong. When you choose to apply fast lanes in solving certain questions, sometimes such fast lane may just apply to one particular kind of question. If the question is adjusted, changed somehow, it becomes a problem. And that is why it's always good to know the right way of doing something before you start thinking of other fast ways if necessary. Although, like in this case now, all I was supposed to do is to notice that after 50,000, tens of thousands, the next number that is supposed to come is supposed to be 1,000. And because there is no 1,000 here, it means I'll fix what? 0 there. So that even if I decide to extract the first digits, it will be 5 from the 50,000. There is no 1,000, so you extract 0, then you move on to 100, you pick the 5, move on to 10, you pick 3, then this unit. Like I said, the best thing, go by your place values. This is in tens of thousands, so I'll write TH, take it down to units. TH, 100, tens and what? Unit. Then looking at this, I'll start extracting the first digit of these numbers. 50,000 should come under tens of thousand. I will pick 5. Then this is 500. 500. Will it come under 1,000? No. This is 1,000. This is 100. So this 100 is meant to come under this place value 100. 500, you pick this 5, fix it under this. Then this 30 is under tens, 30 is in tens. 6 is one digit, so it's units. Now, 1,000 is empty. So what do? You fix up 0 there. Therefore, we could say that 50,000 plus 500 plus 30 plus 6. The number it represents is equal to 50536. And this is 50,536. 50,536. If I let me write it in words. In words. 50,536. Right, so that's what we do for you from the GMAT 41. Giving you the foundation of anything you are meant to learn. We have a whole lot of secrets. GMAT 41 has a lot of fast lanes of solving a particular problem, but we show you the reality. And when necessary, we show you the fast lanes of doing that. We shall now move on into writing decimal numbers in expanded forms.